Okay. Okay, good afternoon.
Good afternoon.
My name is Mino Negrin. I was asked to speak to you about my company, my entrepreneurship, my initiative. You saw something regarding the water. Well, actually, we are speaking about that. But first, I was almost in your same situation. What it was quite a long time ago, almost 35 years ago. I think that maybe I will share with you some of my personal experience. I was born in Italy, in Milano. And I was, I don't know, you come from California, understand? And I was as well very, very spoiled, very, I don't know as well, but anyhow. I was a spoiled Jewish guy. I went to Jewish school. I have a Jewish formation, Jewish education. At a certain point, when I almost very, very close to when I finished high school, I decided to make a move, a very, very important move for myself. And I decided to make my aliyah. I came from a very, very well-established Italian family, Jewish Italian family. And I tell you, here in Israel, actually, there is still not the same espresso that I can drink at home. For sure, not the same gastronomics, but I thought that we have here a one-time opportunity as the Jewish people to make something very, very important and to make some kind of change. And I felt, together with a group of friends of mine, I felt some kind of responsibility, together with an excitement of being a partner in this one-time opportunity that the Jewish people have to change things here in our state. And I know you have been well indoctrinated during those days, and you cannot have to hear some more about that. But this is my personal experience. And I made this decision, and I came when I was 19 years old, when I finished high school. I was in a kibbutz for 1 year. Then I went to the army. I served for 2 years. And then I went at college, at university. I studied management and industrial engineering in the Technion of Haifa. You have been at the Technion? You are going to visit? Well, one of the best schools of engineering worldwide. Okay, and I studied there industrial engineering, and I finished in 1989. My family has always been in Italy, and unfortunately my mother and my father are not with us anymore, but they have been living in Italy. And they were, we were a family of Jewish, how do you say, my father was in commerce. He was buying and selling watches, a very, very good business. And I was here, okay? So when I finished the university, my father came here and he asked me, okay, what now? And I told him, look, I'm now an engineer, and I have several offers to work as an engineer in a company. And he told me at that time, look, I think of something else that we can do together. And I asked him, what are you thinking about? And at that time, we are speaking at the end of the 80s, he told me something that has influenced my life and also, as you will understand, also the life of my children and my grandchildren, etc., etc. And he told me, look, Mino, you have to know we are going to work with water. Say, what do you mean? Say, look, water will be very, very soon will be a resource which will be scarce, and we will have a very big shortage. And it's something in which we can start to make some work in it. They say, okay, now you tell me, look, now you are an engineer, and you can work in this field. I told him, look, first of all, there is one problem. Water is chemistry, and the only two classes that I had that I didn't pass in engineering are chemistry 1 and chemistry 2. And that time he told me, look, this can be an advantage. You will think out of the box. Say, okay, but let's hope it will be not too much out of the box. And so we started a company. We started from nothing, actually. I started up a company in the 1990, selling basically water treatment systems, water purification systems. Very, very soon we had the need to build a factory, because actually his vision was incredibly right. He saw in the late 80s what will be the developments in the year 2000, etc. So we had to build a factory. We built a factory in the area of Carmiel, which is north from here. And we started to manufacture units and to develop new technologies, new solutions, new applications in the world of water purification. At the end, I will cut it short. Until 2010, the company was already a company which sold worldwide big units of desalination. You know what is desalination? Okay, we are manufacturing drinking water from seawater with the most advanced technology, and we had the sister companies in all basically in Chile, in Australia, in Italy, obviously, in Spain, in Cyprus, in several places of the world, and it was very, very, very successful. So at that time, in 2010, what happened? The company was so successful that we received a very good offer, the famous offer you can't refuse, and I sold the company for a very good, made a very good, very, very good deal. By the way, I sold the company to the Estée Lauder group, and it was very, very successful. And I thought I will go. That's it. I will go to pension. Okay, I will retire and make other things. And I registered to the Hebrew University, and I started to study Jewish philosophy. Some of the ones that you saw here, Maimonides, Spinoza, etc. Those are guys which I learned very, very, very intensively. But then, and now we start the reason why I'm here, and the company that I am now dealing with and promoting. A professor from the University of Tel Aviv came to me with a very, very interesting patent, very, very interesting device. What I will do now, I will show you a small short movie on what is the device and what we are doing with this device in the humanitarian field. Later on, we will go a little bit into more details. By the way, feel comfortable to ask questions whenever you want. Okay, we can make a discussion. We don't have to make a frontal presentation. How I can get into the YouTube?
אתה רוצה ליוטיוב?
אני רוצה יוטיוב, כן.
ויש לך לינק מה...
אני יכול לרשום, אין בעיה.
אז רגע. אבא גם.
פשוט היה צריך להיות אסקייפ, זה שקופית תיכונה כזו, וזה פשוט מין יורד כזה, אתה יודע, מחביאים את זה.
אבל איך אבל שני מחשבים שם.
אז עכשיו הוא פשוט עובר למחשב פודיו, בשביל שזה יוצג, ואז חוזר ל-HDMI בשביל שהמחשב שלו יוצג.
עכשיו אני יודעת.
רוצה לשמוע.
רגע, אתה לא כותב? אוקיי.
Okay, I will show you now this movie. I have been in water filtration. You will still hear my voice.
Hey, that's you.
A lot of techniques and several technologies, but the application which most touched my heart, really, was the one in the humanitarian field. To produce pure water to people who have not approached to clean water, almost at no cost, and with very, very limited resources.
Producing pure water where electricity is simply not available is a huge advantage.
I was approached by Professor Yoram Lass from the Faculty of Medicine at the Tel Aviv University, who told me an interesting story. He told me, look, I have a patent, which I already filed, which provides for the reuse of a medical device, actually with the artificial kidney, in the field of water treatment. I say, look, it is, looks very, very strange, but I will be happy to see it. And I understood at that very, very moment that this can make a real change. Is to transform an idea into an industrial project. How to do that? By sterilizing them according to procedure dictated by the FDA. And in 25 years in this business, I never saw a water quality like the one which was produced by those filters. Use filters actually, from the hospital of Nahariya. Professor Nathan Levine, one of the most known nephrologists in the world, was visiting the hospital.
Dr. Crystal, who's the head of nephrology there, introduced us to Mina. And we discussed with him the possibility of having a small device which could be used in small areas where water was polluted and contaminated and could be treated on the spot.
You can literally build the thing in your garage.
It's not exactly the garage, but it's something, it's at the warehouse. But yes, basically yes. Another man of big importance in this project is Dr. Seth Johnson. Without him, we couldn't have any kind of approach to the field and to learn from the field what are the main instances, the main problems in the application of the water purification device which we are producing.
Dr. Levine had actually approached me to verify whether we could actually work together and actually try to eliminate the preventable causes of what we call acute kidney injury.
We set up these prototype devices of Mina's invention, headed by Omri from Israel, and it was successful. We were immediately able to show that we were getting drinkable water.
as soon as you start to pump the water from the river, immediately you will get clean water to drink, and that was like a miracle for the people.
Just a second. Just this, what you see here, this pond, okay, is actually the drinking water source, which is used by the village, which we are now treating their water. Okay, this is the usual, by the way, the usual scenario in Africa, from where people are getting drinking water.
Drink from this, but from this I would, yeah. So I want someone to try and operate with
this. Is the quality of the water.
You want to try this? Step down. Yeah, easy. Okay, yeah. That's it.
One of the main characteristics of the system is that it is a multi-use one. Once it gets clogged, you can backwash it outside and then reuse it again and again.
The reaction was truly amazing. The people said in the native tongue that this tastes like mineral water from the bottle.
There's a before and there's an after. Before, there's infection, there's acute kidney failure, there's dehydration, which is fine water. And after, almost the same.
Our next step will be to reach a wide range of people, not to provide good drinking water, in order that it will provide more water for the people.
The device is 20 kilo, which is more or less 44 pounds. Okay? So, actually, this is the device. Okay? This is the device which is around all our activity. This is basically, as I said before, an artificial kidney. What this means? This means that when somebody has kidney, the kidneys are not working well, meaning that the blood is not purified, okay, internally in the blood. You need what is called a process of dialysis. I don't know if you heard about it. This is something that you go to the hospital or to the dialysis center. You sit on a table or you sit on a chair. Then they take you the veins, one vein. They connect it to a pump, physically, okay? And the pump is connected to a pipe. It is connected to the pump, and the pump is recirculating the blood through this filter, okay? And the filter is purifying the blood. After 2 hours, 2 or 3 hours, depending on the patient and depending on how acute his problem is, his blood is now purified. By the way, not having a functioning kidneys, he will have to return in 2 days, 2 or 3 days. So it's a very, very bad thing. But basically, after one time that this has been used, okay, 98% of dialysis centers are taking the filter and throwing it away. Okay, and obviously it has to be disposed, have to be buried. It's not like that to throw it in the waste bin, etc. And although there is a procedure, a procedure which is approved by medical standards to sterilize this filter and to reuse it in the dialysis, okay, but at one condition, has to be reused by the same patient, okay, and therefore it is a logistic nightmare. You have to take care that the filter which has been used by Bob will be reused by the same Bob and not another Bob. It is a real nightmare, and therefore 98% of the dialysis centers taking the filter and throwing it away. This Professor Yoram Lass, the professor from the Faculty of Medicine to Tel Aviv, which is actually not in the water treatment business. And to be honest, this is a patent that somebody who can think about only if he is, you remember, out of the box, outside of the water treatment field. thought that this can be used for another application, and proposed to me to use it in water treatment. Now, basically, what we do, we take the filters from the waste bin of the dialysis center, physically, okay, physically from the waste bin, which are they are slightly red, okay. Obviously, most of the blood has to be recovered, okay. Otherwise, they will be the patient will not feel well. But we physically take those filters from the waste. We make the same sterilization that has to be done in order to reuse the filter in dialysis, but instead of working to reuse for dialysis, we use it as a water filter. By the way, this filter, and you can pass it through you, did see blood of a patient, has been sterilized again, and as you can see, it is completely new. It seems completely new. Now, the issue is that we can reuse. I will switch to the presentation. How can I do that? This way. This way. אוקיי. זה גם מדלג? אני צריך. לא? אוקיי. Yeah, this is basically how it looks from the inside. Okay, I will not bother you too much with how it looks, etc. But if you want to see it, here there are small fibers, very, very, very small fibers, okay, which are acting as a filter. Okay, the fiber has a very, very, very small pores. Okay, and basically what happens with this filter, with this one that you are looking at, it filters the water, but it does another thing very important. It removes any pathogens, any bacteria, and any viruses. It removes all, sorry. It removes all the viruses and all the bacteria from the water. This means that by one pass of water through the filter itself, you are getting water which has been filtered and decontaminated, practically sterilized. Okay? With one pass of water. Yes, please.
How long do those last? Do you have to replace them?
Those ones? Actually, it's a very good question because we don't really know. And I will explain you why. We started to use them 3 years ago. And until now, and this was actually the first time which those filters has been used in water treatment. And from 3 years ago until today,
none of them are broken.
They work. So basically, we are now giving warranty for 3 years on those filters, on the filter itself. Really, exactly. This is how it works. This is a completely empirical issue. If you will come next year and they will still work, I will give you a warranty of 4 years. Okay? So this is how it works.
So you're growing the warranty.
Sorry?
You're growing the warranty.
Yeah, because this is the first time that this application is being used at all. Okay, so this actually is a question which is an open question, but it's a very good one.
It's an ongoing question.
Yeah, ongoing question. Yes, at a certain time they will for sure I don't know collapse, but for sure lose the I will explain. Lose their characteristics, okay, at a certain time. It is a synthetic material at all, okay? It is a polysulfone, it is a synthetic material, which means that at a certain time it will lose the characteristics. But something which is very, very important, okay, which is the whole idea. We are using a filter which has been used as a medical device. Not only used, has been designed as a medical device, has been manufactured as a medical device, meaning that the best materials, okay, has been used in order to build this filter, and on the top of that, has been quality test according to medical standards. What this means? This means that they put those filters, the original manufacturer of those filters or those devices, are putting that on a testing scale, on a testing bench, and they check one by one. If some of them is not really cutting, okay, is not really cutting the, let's say, the bacteria, it's not removing bacteria, it is discarded.
So if it doesn't work 100%, they don't count it.
They don't count it, exactly.
Wow.
Yes, please.
I have a question about the rights of the device because you are using someone else's device.
No. Sorry, it's saying no in this. It's the Israeli way, my friends. I have 35 years. I already got.
There is a company that.
There is a company which has been the original manufacturer of those filters.
Yes.
Once they sold it, okay. And by the way, we are in very strict contact with those companies because they like very much the fact that they are reused and not just discarded like that in the environment.
So you do have an agreement with them?
No. I don't need an agreement. I don't need an agreement. If I have this phone, okay, Apple is selling the phone. Is selling the phone to me. Do they have the and I am buying from let's say you are buying for me the phone, okay? Do Apple has any kind of right on that? And I'm using that for, let's say, I don't know, given it, I don't know, to throw it on somebody. I don't know.
I think they think that they do.
They don't. They don't. It is clear. Once a company sells a product, it is not its product anymore, and they cannot ask for any kind of property on that. Okay, they sold it already. This is obviously an issue that before entering into this project, I obviously checked.
Even though it's their technology, once it's being sold, it's not their technology.
Well, yes, but actually we are not using it for the original reason that they manufactured it. Not only that, we are using that also in a different way. Okay, so basically we have in our hand a device, a filter, which actually, and being 25 years in this business, I have been using all kind of filters in very, very wide range of application. And having this, we are having a filter in our hand, which has the best characteristics available in the market. There are no filters which are rejecting 100% of bacteria. There are no filters like this one. We call it in the range of what we call UltraFiltration. Okay, I don't know if I have a slide on it. I don't know. I will check later. But anyhow, there are no filters which are manufactured by companies which are in water treatment, water filtration, that are as accurate and as strong, as robust as this one. And on the top of everything, we don't pay for them.
That's the greatest part.
We don't pay for them. Okay. Not only we don't pay for them, there are places in the world, not in Israel, and I think. Okay, let's say not in Israel, but there are places in the world where the hospitals, the dialysis centers are paying in order to dispose them. Okay, so it's not only it is clear that you cannot throw it just like that. Okay, so there will be also a model where theoretically we don't look at that actually, but theoretically we can also get money from collecting them. Okay. So at the end we have a filter. You saw in this short movie the characteristic and the let's say the capacity of this filter, which doesn't cost anything and makes the best work of all other kind of filters in the same range. This is the idea, and this is what convinced me actually to. I continue Jewish philosophy, but let's say actually at a lower pace. I am only now I finished my BA and starting the master, but very, very, very slowly. Anyhow, yes, please.
Have you ever used this at the Dead Sea?
the Dead Sea. Okay, this filter cannot remove salts. Okay, it's not removing salts. It removes what we call colloidal matters, particles. Okay, it removes, as I say, bacteria. It removes viruses. It removes organic matters. But water and salts are passing through. Yes.
So I know in the normal function of a dialyzer, there's like a working fluid, like the blood passes and then a dialysate passes.
Very good. From where you know that? Huh?
I took a class on that.
Ah, okay.
So what's the second fluid for your?
Very good. Very good question. Actually, I have a question from a professionist. So I have to find. Wait. I will search.
Pure water, where electricity is simply not available, is a huge advantage. Because look, I have a patent which I already filed.
Sorry for hearing that again, but there is a
reuse of a medical device, actually with artificial kidney, in the field of water treatment.
Here you go. How it works, this thing? It doesn't.
It's kind of working.
Ah, no. Sorry.
I have been in
Sorry. You will be a...
water desalination with a lot of techniques.
I say, look, okay. Now, I will do it. Here we go. Okay, as this guy, what is his name? Jonathan. Actually, say this is how it works in the hemodialysis. Okay, here you have the vein. Okay, as I told you, here you have the blood pump, and then the blood goes into those fibers. Okay, those are basically the fibers. The fiber is a hollow fiber. Okay, it's imagine. I don't know. You have no. Give me a לא, חתיכת נייר. No. Wait. Okay. Imagine this is a fiber, a hollow fiber. Okay. This is the inlet. This one. Let's imagine this is the fiber. Okay. And this is the inlet. Okay. What happens is that there is here a porosity of the fiber itself, which actually something is retained into the fiber and something is expelled. Okay. Now, what is going on in the dialysis? The blood is going this way, and it is going back. Now, okay, so the blood is going inside and is going outside. Now, what's happening is that there is a fluid, which we call a dialysate, or how do you say it? You have been at this class. What is the name? How? Dialysate. Yes, but I don't have the correct accent. I have still the Italian one. So actually, the dialysate, which is a salty solution, which is recycled in this way at the outlet of the filter, okay, at the outlet of the fiber. And what happens? I don't know if you heard about the process of the phenomenon of diffusion, okay. In diffusion, what's going on is that if there is a salty liquid, it will take out the salts from another solution. Okay, this is the reason why you get, if you will be in the sea for a long time, at the end you will dehydrate because you are trying to dilute the sea. Okay, so you are trying to dilute the salinity of the sea, and this is the reason why all the water will go out from your blood, from your body. So don't try it. So so this is the way in which it works. Now, what's going on is that in the blood the contaminants, the pollutants of the blood are urea, creatines. Those are things which are actually the poisons which the kidney is not able to remove, and has a low molecular weight. Meaning low molecular weight means that they are small. Okay, they can pass through the filter. Okay, they pass through the fiber, and they are being attracted by this salty solution, while the blood, together with its component, is staying inside. Just for giving you an idea of what's going on, the blood has a component which is named albumin, which has a high molecular weight, and has to be retained into the fiber itself. Otherwise, blood without albumin, the patient will die after a while. Okay? So this is the way in which it is used in dialysis. What you are going to say now.
So how does it work?
Exactly. So how it works in water, because it's not the same way which it works in water. This is the correct question. In water, we use it in another way. We use the porosity of the fiber. Water is going in from here. Sorry, no, the contrary. Yes, excuse me. Water is going on from here and from here. Okay? So all the bacteria which has a high molecular weight, a big size, are retained into the filter itself, and water together with salts is going out. Oh, very awesome, yes. It's a very, by myself, being in a water business, I could never think about something like that. Yes, please.
Well, you developed the technology 3 years ago. What do you estimate has been the reach in terms of how many people you've been able to provide this technology?
Yeah, actually we have several applications. I was getting to it. Sorry? No, it's okay. We have several applications. One of it is in the humanitarian field, in what you call with drinking to get drinking water, and actually it's a dream. It's a dream, guys. How much cost this unit that you saw? Give me a price. How much? No, come on, $100. I mean, huh? Huh? No, come on. It is too less. No, we actually no. This activity in the humanitarian field, we are making it on a no-profit base. All the other applications that we have, and I will show you in a moment, we are making it for the mass profit possible. But the one in the yes, that's clear. I mean, I have workers, I have a family, I have how do you think? But the one in the humanitarian field, we are making it a no profit. This means that we are doing that for the cost of the device itself. Okay, how much it costed us? Obviously, we are factoring. Just a second. No, not free. No profit. This means that you are, if you are investing $1, you will sell it at $1. That's it. But actually, we are factoring inside also obviously the cost of the development, etc. Taglit, as we say, we sell it at $900. $900. Now look, $900. The system that you saw is manufacturing 8 liters per hour, almost let's say 2 gallons per hour. Per minute. 2 gallons per minute. Wow. Now 2 gallons per minute, just for giving you an idea. It's the need of, let's say, obviously in those circumstances, so let's say between 500 and 600 people. So with less than $1,000, we are giving drinking water at one-time investment with absolutely no other operational cost, no chemicals, no energy is involved, nothing, only the human power of pumping the water and passing it through the filter, okay? We are giving, with less than $1,000, drinking water to more than 500 people which until that very time didn't have anything to drink safely. They did drink, okay, from what you saw. The mortality in those places is very high, mainly the children mortality is very high. There is a statistic which is world known, okay? Almost 4,000 children are dying every day, okay, because of reasons which are linked somehow to the water quality, okay? In the places that you saw, in the places that we have installed those systems, there was a very big problem of a illness which is called acute kidney injury, which actually is caused by dehydration, diarrhea, etc. There were very big problems, and actually this is all related to the water quality. From the time that we installed them, the first ones were in May 2015. The rate of illness is 0, not dropping. There are no more cases of people who has contracted this injury, this illness. Okay, this means saving life. Very, very simply. And to your question, what is the we have just started now this application. We got already tens of units which are working in several villages, but we are only at the start. So we are going to NGOs. Basically, Dori, who is here, is in charge of all the humanitarian field, and we are approaching all the various NGO. You know what is an NGO? Non-governmental organization, which are dealing mainly with those problems. The UN agencies, Red Cross, etc., etc. Please.
So were you selling it for the actual profit? Who else do you use technology?
Sorry?
So like you said that
Other applications you are asking. Okay. Okay. I will show you some. First, I will show you the nicest one. Okay? Wait. לא, תודה. כן, אם אפשר, כן. מה? זהו? Wow. We ran out of time. 5 minutes. Okay, I will tell you in another very nice application, which actually we are doing for the much profit as we can, as I told you, but it is very nice. Swimming pools. Why swimming pools? Who is able to tell me why in swimming pool it's a very good thing?
For skin.
No, okay. In swimming pool, I will tell you. I will explain. In the swimming pool, the usual. There is anybody here who has a swimming pool? How many people have a swimming pool here? I'm searching for customers. Yes, actually. Okay. You know how the swimming pool is working? How it is filtered, the water? Very simple. Okay. There is a pump. Okay. There is a pump which is recycling the water all the time through a mechanical filter, okay, which is removing particles, sand, or things like that. And then how you take care of all the bacteria, microbiological issues, etc. Huge amount of chlorine which are inside. This is the reason why you are going out of the swimming pool with all your skin has a very, very bad smell. You have to put the small glasses, etc., etc. Okay, this is the usual scheme of treatment. Now, yes, what we do with our filter? Don't forget, we are filtering, and at the same time, you are removing all the bacteria. So basically, if you recycle the water of the swimming pool through the filter, you will remove all the bacteria, and therefore you will need almost no chlorine.
You can literally drink your pool water.
That's for sure.
What?
No, absolutely. You can drink your pool water. Not only that, you are taking a bath in your swimming pool, like exactly with the same water which you shower. Exactly the same.
So you can have
Okay,
giant bubble
and this is what I do in my swimming pool, for example, in my friend's swimming pools, other places where this device is installed.
Is it in your swimming pool?
Of course. This is what I was the first. Yes, please. Sorry. She was asking before. Sorry, I can't hear you.
Is there a way to use the technology in a more affordable filter, like a Brita filter, the water bottle?
You see, we are limited, actually. There is a limit to this technology that at the end, we have only one device. Okay, this is what we get from the medical center. Okay, and so we can actually, we can do a lot of, we can upscale, but we cannot make it in a small scale. Yes?
Do you see yourself maybe going public anytime soon?
No, I don't need any kind of how do you say, of not investment, and also not, I don't want any kind of איך אומרים שותף, נו? Partner. I am very, very happy as I am now. Yes?
How much do you pay to be able to make it? How much do you, what is your cost of production?
Cost of production of the system, as I told you, this is the small device is $900.
No, isn't that the price that you sell it at?
This is the price. No, okay. As I say, in the humanitarian field, the small devices, what I say that it costs $900 and it manufactures 8 liters per minute. $900 is the cost of production, and we are factoring inside also the cost of the development, the patent, etc. But there it is one field of work. In the other ones, we are having very, very nice profits. Yes.
I have a question. Do you have any competitors? And also, like, because you just get it from hospitals that just want to give it to you for free, wouldn't it be what's the barrier to entry into this business?
Yeah, good question. The first one actually is that we have a patent. We have a worldwide patent on the application. This is what I was saying. Okay, so nobody can legally take a filter from a dialysis center, sterilize it, and reuse it into water treatment. So we have a patent. Sorry?
With or without your consent? Could you do it with your consent?
With my consent for sure, but then it will not be any more rentable for him, obviously. Yes?
How much do medical people pay when they buy these initially?
Good question. You have a good question. One of those filters costs $40. It is a medical device. Don't forget, it is a medical device.
All that in-depth testing they have to do on it?
Sorry?
Even with all that in-depth testing they have to do on each one of those?
What do you mean?
It's only $40.
It's only for that. Well, you know how many of those? But there is a question which was not asked, which is very important.
How many of those are produced every
Very good. Now that I told you, how many of those, I want to guess, how many of those are manufactured every year, used and disposed, let's say in the US? How many? Every year, per year? Come on, million. How many? Million. Who gives more?
Has to be more.
10 million. Who gives more?
Is it in a billion or no?
9 billion. Come on. A year, yeah. 30 million of those filters, 30 million of those filters are manufactured every year and disposed. So actually, one of the main questions of the barrier, which we could have, for example, the availability of those filters. Okay, if there are only few filters available in the market, or even in the waste, let's say, this would have obviously compromised the business itself. But there is almost unlimited availability of filters.
You have a surplus.
In the world. Here in Israel only, we have 1 million filters per year, which are used and disposed.
Okay, thank you.
Thank you.